Good evening, all. So, hope my voice is audible to everyone. So, is it audible, guys? Shall I get quick confirmation? Yes, thank you, guys. So, what about my screen? Is it visible to everyone? Thank you, all, guys. So, still many has to join. So, we have time. Please do inform to your friends, guys. So, let them join immediately. I want to I want to ask you one thing, guys. So anybody is accessing lab? Anybody started accessing lab? Do you have access to lab, guys? Not yet. Okay. Can anyone do this, guys? Parallelly, can anyone try with this? Can you type OSHA? OSHA bits on Google. OSHA bits Pilani. Okay. I will type OSHA, OSHA bits Pilani. Type it on Google, guys. OSHA bits Pilani. So that will redirect you people to OSHA-bits.codeargo.net. Am I right, guys? Is it redirecting to that page? Yes. Can you? Yes, correct. Okay. So can you click on login button? Can you click on login button? So here you are getting login button, right? So can you click on login button? So once you are clicking on login button, it is asking for your credentials, right? So can you try with your credentials? Okay. So I think you people are redirected to this page. Am I right, guys? So if anybody is getting this page, so can you put a login means okay. So can you put a snapshot? So what is available there? So is it showing big data? So can you click on course? Can anyone click on course? Yes. So look at here, guys. So once you are clicking on that, you have to click on this course. So in course, it is going to list. So it is going to list BDS. Okay. You people are belongs to cloud computing, right? So it will show lab list like this. Is it showing? Once again, guys, be on the line. I'm sorry, guys. Actually, I did not see. I was on mute. Thank you. Thank you for confirmation. Yes, guys. Yes, I think everyone are getting lab access. I will show you once I complete the syllabus, guys. I have not yet touched upon your lab concept. So once I am touching on that, then I will come back to your lab access and I will show you later. Okay. So better you people are come out of the lab. Come out of the lab. Don't leave as it is. So once you have logged in, means it is mandatory you have to come out of it because it is utilizing the space actually. Is this clear? So you all come out of the lab, guys. So once you all come out of the lab, so put a message on chat box and please be ready for today's session. You all ready, guys? Can you all put a message on chat box, READY and chat box? So once you are ready for today's session, please do put a message on chat box, READY. The manual and all I will post you guys. Soon I will post you manual. No need to worry now. Yes. Thank you all, guys. Okay. Yes. Hello, everyone. Once again, good evening. So only I have 37 students. I don't know where others. Okay. So you please put a message on your group. Suppose you have a WhatsApp group, means you put a message on WhatsApp group. So ask everyone to join immediately. Guys, actually, yes, I have told you, right, I'm lacking completion of syllabus. So today, I'm touching upon third session of big data system. It is not fourth session, it is the third session of big data system. I hope you all are doing well and are excited to dive deeper into this fascinating topic. So as always, uh, I have to start with one thought. So today I've taken one inspiring thought from Thomas Edison. What he has said, guys, the value of an idea lies in the using of it. So this is so true in our field, right? So it is not enough to just have data. The real value comes from using that data to create something meaningful. That exactly what we will be discussing today, and why how we can leverage data to create a value through analytics and robust big data systems. Okay, so let me share my screen. Okay, fine. So guys, this is the topic we are discussing on today's session. Okay, so this slide is a quick recap of what we are covering in today's session. So as you can see here, the main topics are divided into two parts. So one is analytical part and another one is characteristics of big data system. Okay, along with that, so we are going to focus on big data analytics. Guys, look at here. So first, we will be get a clear understanding of analytics. So what is it? How organizations mature in their use of it, and the different types of analytics that exist. And we will then move into the next very, very important concept, that is big data analytics. Okay, that is exploring its unique characteristics, challenges companies face when adopting it, and the specific requirement for such system. And we will also touch upon the technologies, hurdles, and some popular technologies that address these, like Hadoop, Spark, okay, and then cloud, so on and so forth. And finally, we will take a case study on case study and NAS DAQ. Okay, NAS. So we'll provide a great real world example. And yes, the second half of our session will focus on the foundation aspects of the big data system. So this is a very important part, guys. and without a solid foundation, any system, especially a distributed one, so will fail. So we'll talk about living with failures, so which is common reality in distributed systems, and the critical concept of reliability, availability, and also consistency. Okay, guys, so what I would like to say now is this knowledge will not only help you to pitch a big data project proposal, but also to build the system itself. Okay, so it is about connecting the why with the how. Okay, so I request each and everyone to pay close attention and feel free to ask questions at any time. Okay, so I think now you people are ready for today's session. You all ready, guys? So everything is paka, right? Everything is perfect, right? You all ready? Yes, thank you all, guys. So now, okay. Guys, the very first slide, I'm talking about a foundational question. What is a foundational question? What exactly is analytics? What exactly is this analytics? So let me ask you this question to you all, guys. What, according to you, what do you mean by analytics? Can anyone put an answer and chat box? Okay, pictorial view, graphical view. Okay. So get the insight of data. Very good answer. Processed information which helps in decision making and drawing meaningful insights. Good answer. So using data, we interface informations to take decisions. Yes. Remove the noise from the data. Very good. So one of my friend is talking about quality of the data and the process of examining data to find pattern, draw conclusions, and make informed decisions. Exactly. You people are all giving very good answers, guys. Actually, let me look at the slide. So what we have mentioned here, see, look at here, extensive use of data, statistical and quantitative analysis, exploratory and predictive model, and fact-based management to drive decisions and actions. So this is the definition. So mentioned in, this is the definition mentioned in your slide. Okay, in simple term, analytics is about moving beyond simple reporting of what happened and getting into why and what next. Correct, no? I think each and everyone will agree with my point. So think of it in this way, guys. A traditional report might tell you that sales of certain product dropped by 10% last month. Okay, so that's data and information. But analytics, however, helps you dig deeper. So it would help you figure out why sales dropped. So was it a pricing change, a new competitors, or poor marketing campaign? Are you all getting, guys? So for each and every question, it is going to give an answer. Okay, guys, the main purpose of analytics is listed here. So look at here. I have listed 4 points here. What is the very first point? To unearth hidden pattern. See, for instance, you might find a correlation that's not immediately obvious. Okay, so here, look at the example given here, guys. This is the great example I've taken here. See, 2 out of 100 stores had no sales for a promotion item because it was not in the right shelf. So this is a hidden pattern that can be discovered by analyzing sales data and store layout information. I think everyone will agree with my point. And what is the second point I've taken here? To decipher unknown correlations. Okay, the best example for this is the beer and diapher. The beer and diapher example. Guys, the beer and diapher story is a classic example we can take to explain the second point. So retailers found that men who bought diapers on a Friday evening also frequently bought beer. So this was not something you would intuitively know, guys, but data analysis revealed this correlation, allowing them to place these items closer together to boost sales. Okay, and what about third point? Understand the rationale behind trends. See, instead of just knowing a product is popular, analytics helps you to find out what users like about it. So is it the color, the feature set, or the customer service? So this helps you to replicate success. Okay, so then what about fourth point? Mine useful business information. So this could be as simple as what? Identifying popular items during specific holiday sales. So this insight is extremely valuable for inventory management and marketing campaign. Guys, ultimately, these insights helps in several key areas. What is the first key area we have mentioned here? Effective marketing. Guys, I would like to tell you now, by knowing your customer better, you can create more targeted and effective campaign. I think everyone will agree with my point. And what is the second? Better customer service and satisfaction. Correct? No? You can anticipate customer needs and address issues before they become major problem. And third one is competitive advantage over. No. Before that, we have one more point. Improved operational efficiency, right? So here we are trying to what? Identifying bottlenecks and inefficiencies in your operations can lead to significant cost savings. And finally, we have competitive advantage over rivals actually. So if you are the only one using data to make smart decisions, you will always be one step ahead of your competitors. Guys, this is the power of analytics. How many of them agree with my point, guys? So once you are agreeing with my point, so please do type agree and chat box. Please do type agree and chat box quickly. My dear students, it turns raw data into a strategic asset. Am I right or wrong, guys? Yes. Now let's look at the what process of how we get from raw data to these valuable insights. Okay. So now I'm moving into next slide. Guys, you just look at the diagram given here. Okay. So this, see here, I'm talking about process of analysis. Okay, so this slide beautifully illustrates the journey of data from its raw form to actionable insights. So it is like a what? Pyramid, right? So with the data at the base, see here, data at the base and actionable insight at the top. Guys, at the bottom of your pyramid, so we have data. So we all know the definition of data, right? So data is what, guys? Data is the raw, unprocessed stuff. So think of sales transactions from a retail store. It is just a long list of numbers and product codes. What is the first step, guys? The first step is collecting data. Maybe you all know about this, right? First step is collecting data. Okay. Now, the next step is to transform into data into information. Okay. So this is done by organizing and summing the data. Let me take one example to explain on this, guys. You can take those raw sales transactions and aggregate them into weekly sales totals for each store or product. So this gives us a clearer picture than the raw transaction log. So we are now beginning to attach some context So moving up, we get the knowledge. So this is where we start analyzing the information. Correct, no? The key here is to add more metadata to provide context and make it meaningful. Guys, we don't just look at the weekly sales total. We add factors to explain them. Okay, such as promotions, social media mentions, pricing changes. So this allows us to understand the why behind the numbers. See, for example, we might see a spike in sales and realize so it was due to a 20% discount promotion. And finally, what do we have here, guys? So finally, at the top of the pyramid, so we have actionable insights. So this is the result of synthesizing. I think everyone will agree with my point. Okay, this is the result of what, guys? Synthesizing all the knowledge we have gained. So this is the stage where we apply functions and transformations to the data until we get a clear, useful takeaway for the business. For example, the insight might be running a 20% discount. 20% discount on product X. On product X on Thursday. Okay, let me take the day also. On a Thursday evening. Thursday evening lead to 30% increase in sales. So this insight then directly informs decision making. Correct, no? So this process is continuous loop. The insights from one round of analysis can lead to new questions and new data to collect and further enriching the knowledge base. Okay, now that we understand the process, now let us see how organizations mature in their analytical capabilities. So analytical maturity model. You just look at the diagram, guys. Each and everyone. My dear students, so this is a very important concept. The analytics maturity model originally from Thomas Davenport. Okay. Guys, this shows us the journey of an organization from being analytically impaired to an analytically competitor. So here I have mentioned, I have taken from him only. Okay, look at here. I have mentioned the name. Okay, you can use this model to understand where your own organization stands and where it needs to go. Okay, now let's break down each level. So here level wise, they have mentioned each and everything, correct? No? So now let us start with the level 1. So what we have mentioned here, analytically impaired. At this stage, data is inconsistent and poor and of what? Poor quality. Okay, so there is no awareness or interest in analytics from the leadership. And there are very few skills in the organizations to handle the data. So basically, they are not using data for decision making at all. That is the level 1. Okay, so next we have level 2. So localized analytics. So here data becomes usable, but only within specific functional silos. So think of the sales team having their own data and the marketing team having theirs, and they don't share. The leadership's awareness is only at a functional or process level, and the analytical efforts are disconnected. So there are a few isolated analytics, but their work is not integrated across the enterprise. Now I will move to level 3. So this is where things start to get interesting. The organization begins to create centralized data repositories. Okay, so leadership starts to recognize the importance of an enterprise wide approach to analytics. So efforts are now aligned to a small set of targets, and there is an influx of analysts in key areas. So they are starting to see the value, but it is still more of an aspiration than a fully realized strategy. So next we'll move to level 4, analytical company. So this is a significant leap. Okay, the organization has an integrated data warehouse. So this is the key. See, all data, technology, and analysts are centralized here. So this is a strong support from leadership for an analytical component. And the effort are centered on a few key domains. So you have specialized analysts within a central organization. That is at level 4. And finally, we have level 5 here. What is level 5? Level 5 is analytical competitors. So this is the pinnacle, right? The organization is in a relentless search for a new data and metrics. All key analytical resources are centrally managed, and leadership has a strong passion for analytics. Guys, analytics is no longer a separate function. It supports the overall strategic objectives of the entire company. So this stage involves a mix of analytics experts, amateurs, meaning data-driven thinking is embedded across the entire organization and not just in a specialized team. So where do you think your organization is on this model? Yes, anybody can answer. So hope now you are all understanding, right? Now you can decide where exactly your organization is standing by looking at this model. Am I right or wrong, guys? So this model helps you to identify the next step to take to gain a competitive edge. Would you agree with my point, guys? Yes or no? Am I right or wrong, guys? How many of them will agree with my point? You can easily analyze, right, where exactly your organization is standing. Which position? Okay, yes, one of my friend is saying directly. Ajit is at level 2. Okay, so Gautam is saying level 5. Good. Good. Many of the companies are at level 5 now, nowadays, because we are getting plenty of resources. So human resources, analyst, everything. Okay, thank you all, guys. Now look at here, guys. Analytics, maturity, and competitive advantage. My dear friends, this slide provides a great visual representation of how different types of analytics relate to the sophistication of intelligence and the competitive advantages they provide. This is a crucial for helping you to decide which technology to use for a given problem. Correct? No? See, on the horizontal axis, so we have sophistication of intelligence, and on the vertical axis we have competitive advantages. Okay, at the lowest level of sophistication, so we have descriptive analytics. Look at here. So this is descriptive analytics. So this answers the questions what happened. So this includes things like standard report, ad hoc report, query or drill down, and alert. What is standard report means? Standard report means what happened. For example, sales were down last quarter. And next one is ad hoc reports. So how many, how often, where? Correct? No? For example, how many customers visited our website last week? That is ad hoc reports actually. And next we have query or drill down. The meaning of this is what exactly is the problem? Correct, no? For example, what were the specific product with declining sales? That is the example, best example for that. And finally, we have alerts here. So alerts means what actions are needed. Okay, for example, an alert for a sudden drop in website traffic. See, these are all comes under descriptive analytics. Okay, and also guys, these are all about looking backward, summarizing the past. They provide some competitive advantage, but it is minimal because most businesses do this. And moving up, we enter the world of predictive analytics. Okay, so this is where we start asking what will happen next. Correct, no? What will happen next? Am I right or wrong, guys? So this is a big leap in sophistication and competitive advantage. So here we find statistical analysis. Statistical analysis, what it is mentioned here. Why is this happening? See, for example, our sales are dropping because of the new competitor. That is statistical analysis. And next one is forecasting or extrapolation. Okay, extrapolation actually. So what if these trends continue? That is the question we have to answer here. See, for example, if our current sales trend to continuous, will miss our yearly target. That is forecasting or extrapolation. And next one is what, guys? Predictive modeling. Finally, we have predictive modeling. So what will happen next? So for example, this customer is likely to churn in the next 30 days. See, this all comes in predictive analytics. And finally, we have prescription analytics. Okay, or we can call it as prescriptive analytics. So this is the most sophisticated and provides the highest competitive advantage. So it is about not just predicting the future, but also recommending actions to take. So it answers the questions, what's the best that can happen? Okay, so under this, we have experimental design and optimization. So under experimentation, you can see what happens if we try this. See, for example, what happens? So if we change the price of the product, that experimentation we can do here. And second one is optimization. So what is the best that can happen? See, for example, what's the optimal price point to maximize profit? Correct, no? Some experimentation here also. Optimization means here also we are doing some experimentation. And finally, you can look at here, guys, that is comes under autonomous analytics, but that is included inside prescriptive analytics only. So under that, we have machine learning. Okay, so what can we learn from the data? That is machine learning. Okay, so for example, analyzing customer behavior to build an intelligent recommendation engine. And also you can observe here, the highest level is autonomous analytics. So where system can learn and act without human intervention. So this is the future, guys. This is the future. My dear friends, this is the future. Try to remember this. Understanding these different types of analytics will help you to choose the right tools and technologies for your project. So how many of them will agree with my point, guys? Am I making sense to each and everyone? Am I making sense to each and everyone? Yes or no? If I'm making sense to you all, please type MS and chat box. Okay, thank you, guys. Next, to look at here, guys. Now we are talking about types of analytics. Okay, under types of analytics, the very first one is descriptive. Already I've explained you more on descriptive in the previous slide. Okay, but still guys, we need more information on descriptive. Guys, we just discussed. So this is the most basic form of analytics. It provides us with the what ability to alert, explore, and report using mostly internal and external data. Okay, so it is often referred as business intelligence, BI, or performance reporting. We can call it as performance reporting also. The key characteristic here is that it provides access to historical and current data. Okay, the purpose is to report on events and occurrences of the past. And think about standard company report. Okay, so it often uses data from legacy system like ERP, that is enterprise resource planning, or from CRM, customer relationship management. So this data is usually structured and not very large, so making it well suited for traditional relational databases and data warehouses. Guys, this era sometimes called analytics 1.0. Analytics 1.0. Okay, so spans from a mid 1950 to 2009. Okay, the primary question answered by descriptive analytics are, already I've shown you this, right? What happened? Okay, and why did it happen? So these are the questions we have to answer here. The example is given here, guys. You can see the example here. The number of infections is significantly higher this month than last month and highly correlated with factor X. What it tells us, guys, it tells us a specific event occurred and links it to a what potential cause. So this is still a look back analysis, but it is a what critical first step. Okay, so next we have to talk about one more methodology that is called as predictive. So predictive methodology, this is the second type. Okay, so this is moving up the what maturity curve. We arrive at the what predictive analytics. So this type of analytics uses past data to predict the future. So it is a significant shift from simply reporting on a past events. Okay, guys, what I would like to say here is, so this is where we start to use more sophisticated techniques. Maybe you all know about this, right? So predictive analytics employs quantitative methods like segmentations and forecasting, while it builds on descriptive analytics for data exploration. It goes much further. It leverages technologies such as a what model and rule-based system. Okay, a key difference is data itself. Okay, predictive analysis is based on large data sets gathered over a period of time. Correct? No, that is gathered over a period of time. Okay, it also incorporates externally sourced data, and importantly, it can include unstructured data. Remember this. So it is including unstructured data. So this is where technologies like Hadoop, okay, and SQL on Hadoop become essential. This era from 2005 to 2012 is also known as Analytics 2.0. Analytics 2.0. The key questions that predictive analytics answers are: what will happen, what it happen, what it will happen, why it will happen, and when will it happen. Okay, for example, building on our previous case, predictive analytics would tell you the number of infection will reach X in month Y and likely cause will be Z. Okay, so it is not just saying something happened. So it is projecting what is going to happen based on historical pattern. So how many of them will agree with this, guys? So this is a powerful type of analytics, right? But guys, so we can go one step further. So what if we could not predict the future, but also influence it? Okay, that's what predictive analytics is all about. Okay, now we are jumping into third level. The third level is called as prescriptive analytics. So now guys, we are at the what top of the analytical pyramid, right? So prescriptive analytics is it. So this is the most advanced and valuable type of analytics. So it uses data from the past, not only make proficiencies about the what future, but also to make recommendations to leverage the situations to one's advantage. Guys, prescriptive analytics is all about suggesting optimal behaviors and actions. It uses a variety of quantitative techniques like optimization and leverages advanced technologies such as models like machine learning and recommendation engines. Okay, the data used in prescriptive analytics is a blend of big data, guys. It is a blend of legacy system, ERP, CRM. It often requires real-time and near real-time analysis. So technologies like in-memory analysis are crucial here. And this is also known as Analytics 3.0. Okay, and it has been the dominant trend since 2012. Okay, so prescriptive analytics answers the most comprehensive set of questions. What will happen? What will it happen? Why it happen? And what action should be taken? Okay, so this is the most important one. What action should be taken? So let's use our infection example one last time. Guys, look at here. Prescriptive analytics would give you an answer like this, guys. The number of infection will reach X in month Y and likely cause will be Z, and W is the best recommended action to keep the number in month Y below X by 2. Okay, this is no longer just an observation or prediction. So it is the data-driven instruction. It tells you exactly what to do to get the what desired outcome. So this is what gives an organization a true competitive advantage. So hope till here everything is clear. So all three types I explained in detail. So now I think it is crystal clear to everyone, right? So once it is crystal clear, please do type me in chat box CC. Okay, fine. Okay, one second, guys. Sometime this will trouble me. Yes, is including both because it is at the top, right, Ajit? It is at the top, right? Okay. Now alternative categorizations. Okay. So you just look at here, guys. Another way what categorize analytics, apart from the descriptive, predictive, and prescriptive model, so we can also categorize analytics in another way. Okay, this is a more business focused view, guys. So one is basic analytics. Okay, this is the first one, basic analytics. So this is a fundamental level similar to your descriptive analytics. It involves slicing and dicing historical data and creating basic visualization to get simple insights. Okay, so it is about reporting on the past. Reporting on the past. Try to understand this. And the next one is operationalized analytics. This is the second one. So this is where analytics is not just a report, but is integrated directly into business processes. Okay, let me take one example to explain on this. See, a fraud detection system that flags a transactions for review in real time. So the analysis is built into the workflow. So that is the best example for operationalized analytics. And third one is advanced analytics. So this category focuses on forecasting the future through predictive modeling. And this is our predictive analytics. So using sophisticated models to forecast future trends and events. And finally, we have monetized analytics. Okay, so this is the ultimate goal for many businesses. So this is where analytics is used to directly generate business revenue. See, for example, a recommendation engine on an e-commerce site that suggests product to customers. So directly leading to sales. Guys, this categorization helps us think about the business impact of analytics from basic reporting to direct revenue generation. And with these definitions in place, let's now transition to the core of our session, that is big data analytics. So now we are jumping into the very important concept, that is big data analytics. So till here, everything is clear. So if you have any questions, you can ask me, guys. So now we are jumping into the second part of our discussion, that is big data system. So everything is clear: prescriptive, descriptive, and predictive. So for every analytics type, so there are some methods. Yes, yes. We have methods. Shall we move forward, guys? Shall we talk about big data analytics now? Guys, in your examination, see what I'm going to do. I'm going to give you an example. So you have to predict. So this example is belongs to which analytics? Okay, that type of question you are going to get in the examination. Or else I will ask you to give a real-time example on prescriptive analytics or descriptive analytics or any methods. Okay, this is the type of question you are going to get on what your concept, what I've discussed now. Does weather forecasting involves all these analytics approach? Of course, yes, right, Jyoti. Weather forecasting involves all these analytics. See, weather forecasting usually what exactly weather forecasting is going to do, Jyoti? It will take the historical data, right? See, first it will take the historical data. So it will start from the bottom. Correct, no? And then it will move up in the pyramid. That is one of the best example, Jyoti. Not only in quiz, so in your examinations also. Yes, in quiz also you are going to get the questions like this. See, that is to check your knowledge, right? Your understanding, right? Okay, guys. Yes. So now let us focus on our syllabus. Okay. So this is the second part of your course. Quickly, you want to look at the agenda again, guys. So we have successfully covered the first part, analytics, including definitions, maturity models, and different types. So now we are moving to the second major topic, that is big data analytics. Okay. So here we will discuss each and every point in detail. Okay. So now look at here, guys. Look at the diagram. So what makes analytics, big data analytics? What makes analytics, big data analytics? That is the question, guys. This slide provides a clear definition. So it is a working with the data set with huge volume. Okay. Variety, velocity beyond storage, and processing capability of RDBMS. So let's unpack that, guys. Velocity, volume, variety, and velocity. So these are the three V's of big data system. So many times you have seen this, right? So when a data set is so large, diverse, and fast moving that a traditional relational databases cannot handle it. So we are in the realm of big data. Guys, big data analytics is not just about the size of the data. So it is about a different approach. So this already I've conveyed in the very first class. Okay, guys, see, look at here. So this uses principle of locality to move code near to the data. This is a fundamental concept in distributed computing. Okay, instead of moving massive amount of data to a single processor, we move the processing logic or code to where the data is stored. So this is drastically reduces network overhead and speed up analysis. Okay, it requires close collaboration between IT. Correct? No. It requires close business users, close data scientists. So IT provides the infrastructure, data scientists build the model, and business users define the problems and use the insights. It is a team sport. Correct? It is a team sport, right? The goal is to enable better, faster decisions in real time. So this means supporting both batch and stream processing. Okay, so batch processing handles large amount of historical data, while stream processing handles data as it arrives in real time. So ultimately, big data analytics provides richer, faster insight to customers, partners, and businesses. And this is leading to strong competitive advantage. So I think, see, each and every point I've covered here, correct? No, each and every point I've covered here. Guys, once I'm asking you to write a definition of big data means you have to include all these points. All the points I've covered in my explanation. I think now the definition is crystal clear to everyone. Now you can see, look at the next diagram. Okay, what is this diagram is showing? What big data analytics is not. Guys, it is just as important to understand what something is not. Guys, this slide helps us to avoid common pitfalls and friction in big data project. Okay, so big data analytics is not one size fit all. Look at here, I have mentioned here. Solutions based on RDBMS with shared disk and memory. Guys, traditional RDBMS are great for structured, smaller data sets, but they cannot handle the scale and variety of big data. We are all aware of this, right? Big data system often use a distributed architecture with a shared nothing nodes. So which is very different from a single powerful shared disk databases. Okay, it is not only meant for big data companies. Okay, you might think only giants like Google or Amazon can do big data analytics, but that is not true, guys. Companies of all sizes can and should adopt it to gain a competitive edge. It is not only a volume gain. It is not only volume gain. Correct? No? Volume is just one of the three V's. The velocity and variety of the data are equally important here. Okay, see, for example, analyzing fast moving social media data, that is velocity, right? Or sensing data from IoT devices, that is variety of data, right? So this can provide immense value even if the total volume is not astronomical. Okay, it is just bothered about technologies. Guys, technology is a tool, not the end goal. Correct? No. The focus must always be on solving business problems and creating values. And it is not meant to replace RDBMS or data warehouses. See, here I have put a what star mark here. So for this, you can learn, you can go through this study. So this is a common misconceptions, guys. RDBMS and data warehouses are excellent for what they are designed for. Okay, suppose we have to perform transactional processing, business intelligence and structured data. So there it is going to play a crucial role. Big data systems are complementary. That's it. So they are meant to handle use cases that traditional system cannot. Okay, the traditional system cannot. So we'll see this in the what in this case study. Okay, I'm going to explain this case study later, where both systems coexist. Okay, so now we have a clear idea of what is this and what it is not. Now let's explore why there is so much hype around it. Okay, look at here, guys. So this is one of the what beautiful slide. I always like to what explain this slide in every discussions. Okay, I have taken what so many webinars outside. So there also I've taken this slide. So this slide is very, very important for to explain the big data concept. So yes, guys, you might be wondering, right, why big data analytics such a big deal now? The hype is not just hype, guys. So it is driven by real measurable trends. Okay, the primary reason is explosive growth of data. So look at here. So this slide is giving some incredible statistics. So data is growing at whopping 40% compound annual rate. 40% compound annual rate. Guys, in 2010, the world generated 1.2 trillion of gigabyte of data. 1.2 trillion of gigabyte of data. By 20, see that is at 2010 I'm telling you about, guys. In 2012, it has reached 2.4 trillion GB of data. Okay, the volume of worldwide data is expected to double every 1.2 years. Every single day, guys, every single day, 2.5 quintillion of bytes of data are created. Okay, so every single day, guys, 2.5 quintillion. Is it small amount of data, guys? And get this, 90% of today's data is generated in last few years only. Guys, this is staggering, right? So think about the volume of data generated by just a few companies. Okay, Walmart processes a millions of customer transactions per hour. Facebook users post 2.7 billions likes actually and comments per day. And Twitter users post 500 million tweets every day. But data growth alone is not enough, guys. Two other factors have enabled this boom. What are those, guys? The cost of storage has hugely dropped. Correct, no? The cost of storage has dropped hugely. So making it economically feasible to store all this data. And large number of user-friendly analytic tools are now available. So making it easier to process and analyze this data. Guys, this leads to what the slide called the big data cycle. Correct? No. As more data is produced, more of it is stored. And this stored data can then be analyzed and leading to better predictions and steady growth in analysis itself. So it is virtuous cycle. I think this all sounds great, right? This all sounds great. So can you put a message great on chat box? Yes, of course, yes. Yeah, even internet is also one of the what reason. So nowadays, why data is growing. So storage, yes, storage cost is decreased. Internet charges are decreased. And see, at home, everyone are having handheld mobile. Correct, no? Okay. Yes, thank you all, guys. So now look at the challenges. Now look at the challenges. So adaptation challenges in organizations. So if big data analytics is so great, so why is not every company doing it perfectly? Correct, no? This question has to be what answered now, right? Guys, here I'm listing some of the what key organizational and human challenges that arise when a company tries to adopt a big data strategy. What is the first one? Look at here. First one, obtaining executive sponsorship for investment. Guys, big data project requires significant investment in technology and people. I think everyone will agree with this point. Without a strong buy-in from top leadership, so this project will often fail. So executives need to be what? Convinced of the ROI. That is the first challenge. And what is the second one? Getting business until to share data or information across organizational silos. Correct, no? So many organizations operate in silos. The marketing team does not share the data with the sales team, and the operational team keeps its data separate. So breaking down these silos and encouraging information sharing is a huge cultural challenge. So anybody is faced this problem in your company, guys? Can anyone tell me frankly? Anybody is facing this problem in your company? Yes or no? Only one yes, sir. So one team will not share data with another team. Correct, no? That is one of the big disadvantage. One of the what biggest challenge we are going to face here. And third one is finding right skills. So this is the major one. Correct, no? We need a combination of skills here. Business analyst who can understand the business problem, data scientist, so who can build the models, data engineers who can manage the massive variety of data, massive varied data. And these skills are in high demand and are not easy to find. Okay. And fourth one is determining approach to scale. So companies need to figure out how to scale their systems rapidly and elastically to handle the volume, velocity, and variety of data. Guys, now tell me, do they build their own data centers or use the cloud? So this we will discuss more in upcoming slides. Okay. So next time going forward means moving forward. So deciding which data to use. This is also one of the crucial challenge. With so much of data available, so we have structured data, unstructured data, internal, external. So it can be what overwhelming, right? A key challenge is deciding which data is relevant and valuable for making business decisions. And next one is choosing optimal way to report findings and analysis of big data. So once you have the insights, so how do you communicate them to the right people in a way they can understand and act on? Correct, no? A beautiful complex model is useless if a business manager cannot understand its findings. I think this is the what suitable suitable sentence to understand the point actually. And last one is determining what to do with the insights. Finally, what do you do with the what insights you have created? So do you just create a report or do you integrate the insights back into the business process? So this is where real value is created. Guys, all these challenges highlights a big data initiative is not just a technology project. It is a business and cultural transformation. I hope each and every one of my students will agree with this point. Would you guys? Would you agree with this point? Yes. So how many of you are ready to discuss about the technical requirement for big data analytics solution? Can I get the confirmation? Requirement of big data analytics. Okay. Now let us look at the requirement of big data analytics. So look at here, guys. To overcome the challenges we just discussed, the big data analytics system needs to meet some key requirements. So one is cheap, abundant storage. So this is non-negotiable. You cannot afford to store petabyte of data on expensive enterprise grade storage. So big data systems rely on cheap commodity hardware for storage, so which is major cost advantage. Flexible processing options. The system needs to support a variety of processing models, including batch processing for large historical data sets, streaming for real-time data. So it also needs to handle both disk-based and in-memory processing. Okay, so this we will see in future. So once I started explaining Hadoop concept, once I started explaining Spark concept, you will understand. Okay, about flexibility. And next one is open source platform. Okay, the ecosystem is dominated by open source platforms like Hadoop and Spark. Okay, these platforms provide a flexible, cost-effective way to build big data solutions. And next one is parallel and distributed systems. So this is the core architectural requirement. Big data systems must be able to distribute data and processing across many nodes. They prioritize high throughput over low latency. Okay, so this is the key difference from traditional OLTP databases. And finally, cloud or other flexible resource allocation arrangements. Guys, the ability to rapidly provision and release infrastructure is crucial. Okay, the cloud is an ideal solution for this. Okay, here, see, I mentioned here NASDAQ. The NASDAQ case study we will discuss is a perfect example of using AWS EMR case study that we will discuss later, little later. Okay, so here it is used to set up and tear down infrastructure for quick projects. So this flexibility saves a lot of cost and time. And these fundamental technical pillars for any successful big data analytics projects. Okay, these are the fundamental technical pillars. And next, look at here, guys. These are the technology challenges. Okay, now we are getting into the nitty-gritty of the technology challenges. The first one is scale. See, here I have mentioned the first one is scale. So need for a storage that can withstand large volume, velocity, variety of data. Okay, so this is the core problem we are trying to solve. So do you scale vertically? The meaning of this is buy a bigger, more powerful machine, or do you scale horizontally? The meaning of this is you are going to add more smaller, cheaper machines. Guys, big data systems almost always scale horizontally. Try to remember this. And next we have RDBMS and NoSQL. Okay, this is the key architectural decisions. See, RDBMS are great for structured data, but do not scale well for big data. NoSQL databases are built from the ground up to handle massive volumes of unstructured and semi-structured data. So which is a perfect fit for big data. Okay, so next we have compute scale with storage. Okay, a big question is whether compute and storage should be coupled or decoupled. Guys, in traditional Hadoop setup, the compute and storage nodes are the same. So which leverages data locality. However, this means if you need more storage, you have to add more compute and vice versa. So as the what NASDAQ case study shows, a decoupled approach, that is like storing data in S3 and using EMR for compute. This can be what more cost effective when the data size is disproportionately higher than the compute frequency. So this is the very first challenge, guys. And the second challenge is security. We all know, right? Security is the one of the biggest challenge. So most recent NoSQL big data platforms have poor security mechanism. So this is a major concern. Okay, so it is challenging to apply fine grain control to semi-structured data, especially with columnar storage. Okay, the options for inconsistent data models can complicate security measures. Okay, a distributed system with many nodes has larger attack surface. Okay, encryption is often turned off for performance reasons. See, there is a lack of robust authentication techniques, especially when dealing with personal identifiable informations. Okay, so in contrast, traditional RDBMS make it easier to control access at the row, column, and cell level because the data is always consistent and tightly coupled. This is an area where big data system need to mature. Okay, so look at more challenges here. So along with this, we have one more challenge, that is schema. Guys, you all know, right? Traditional systems requires a static fixed schema, so which you must define before you can write data. So this does not work for big data, where the data is often unstructured or its schema evolves over a time. Okay, so big data need a dynamic schema. So which is often referred to as a schema on read. So it is referred as a schema on read. Okay, you can write data to the system without predefining schema. So define the schema later when you read the data. So this provides immense flexibility. And the very next challenge is continuous availability. Okay, or we can call it as high availability. High availability. So data is being continuously generated and needs to be processed 24/7 into 365. So this means the system must have little to no downtime. However, most RDBMS and NoSQL systems still require some downtime for maintenance activities like memory cleanup, replica rebalancing, or indexing. So even large-scale NoSQL systems often need weekly maintenance. So this is a significant operational challenge. Okay, so now let's talk about consistency. So which is very, very important topic. Okay, this is consistency. So how many of them know about consistency? Can anyone tell me the definition of consistency? Because we are going to discuss more on consistency in future slides also. So once I'm discussing about NoSQL, so we are going to talk more on consistency. Can you tell me what is the meaning of consistency? Would compliance fall under challenges or protocol? Can anyone answer to this question? Would compliance, example GDPR, right, fall under challenges or protocol? What is GDPR? GDPR is what, guys? General Data protection regulation, right? You people are talking about the same, right? Data protection law, yes. Yes, yes, exactly. Yeah, answer is given correctly. So GDPR compliance falls under protocol or regulations. So implementing it can be what challenge for organizations, correct? No? And one more thing, guys, actually GDPR compliance itself is a protocol or regulation. Okay. So while the difficulties in achieving compliance might be what considered challenges. How many of them agree with my point? Yes, no? Okay, guys, and now let's move to the next slide. So here we are talking about, I was talking about consistency, right? I asked you people to give a definition of consistency, but I did not get it. Guys, this is one of the what fundamental trade-off in distributed system. Should you go for strict consistency or eventual consistency? So this depends on entirely on the what use case. See, for example, so let me take one small example to explain on this. Okay. A financial transaction system requires strict consistency, correct? No, you cannot have two different bank balances at the same time. So while social media comments can be eventually consistent, so it is okay if you see an old version of a comment for a few seconds. Okay, so this we will discuss later, as I told. So once I'm talking about NoSQL, we are discuss more about consistency there. But what about the second one? Partition tolerant. Guys, in a distributed system, hardware or software failures can cause network partitions, where different parts of the system cannot communicate with each other. A system must be able to continue functioning despite of these partitions. The question is, when fault happens, okay, when faults happens, is consistent data available? So we'll explore this with CAP theorem. So this CAP theorem, in fourth session, we have a separate session on CAP theorem. So there I'm going to explain you more on CAP theorem. Next is what? Data quality. This is very, very important one. Guys, with the volume and variety of big data, maintaining data quality is a huge challenge. So hope everyone will agree with my point. So how do you ensure data is accurate? And how do you ensure the data is complete and timely? So this is especially difficult with semi-structured and unstructured data. So where having an appropriate metadata is crucial for context. Guys, these are the major technical hurdles that big data system must overcome. Okay, and some of the what popular technologies that address these challenges. So here you can see here. So many of them I have mentioned here. To manage the voluminous, varied, scattered, and high velocity data, we need to think beyond traditional RDBMS. Correct? No. So here are some of the what popular technologies that make big data analytics possible. What is the first one? Distributed and parallel processing. So this I'm going to cover. This I have covered in the previous session. So I don't want to what explain you again. So we all know, right? This is a what underlying principle. So as we mentioned, we move data compute to where the data is. So this is not a new concept, but it is essential for big data. And next one is Hadoop. So this we are going to discuss from session 6 to 9. So this is foundational technology for big data, and it is designed for file-based large-scale parallel data processing tasks. And it is great for batch processing and handling massive amounts of data at rest. Okay, so this I will discuss you later, guys. Next one, we have in-memory computing. So this is more recent innovations. Okay, this idea is to use the main memory, that is the RAM, of a cluster of computers to speed up data processing task. Okay, so this we will see when we are going to discuss Spark concept from session 13 to 16. Okay, so you wait for a while, guys. And finally, we have big data cloud. So the last one is big data cloud. Guys, cloud platforms are considered the ideal environment for big data. They offer a services model that helps save cost and provides better resource management. And with cloud, you can provision and deprovision resources on demand. So which is perfect for big data projects. So we'll have dedicated session on this as well, guys. So everything we are going to discuss in upcoming slides, guys. Guys, these technologies are not mutually exclusive. They often work together to form a complete big data ecosystem. Okay, so now we are diving deep into Hadoop concept. So till here everything is clear. So shall we dive deep into, yes, asset concept, everything I will explain in the next coming session. So how many of them heard about Hadoop system? How many of them heard about Hadoop system? Everyone? So that is part of our big data, right? So now we are starting with Hadoop. Okay, many of them are saying no, no problem, Priyanka. Haven't worked. Okay, this semester you are going to work on that. I just show you how you are going to execute basic commands in Hadoop. Everything I will show you guys. No need to worry. Okay, good. So many of them not used, right? This semester definitely you are going to use it. Okay, guys. Now let us take some introduction on Hadoop. So I think this is one of the very interesting concept. And this is very much important for your big data. Okay, so now let's formally introduce Hadoop concept. What problems does it solve? And the first problem is the storage of huge amount of data. So when you have massive data sets, you cannot fit it on a single machine. Okay, there are so many problems for that. So what do you want, guys? The problems are you need a partition the data for parallel access, and more systems means more failures. So which is major concern, and multiple nodes can make the system expensive. And finally, the data can be arbitrary, from binary files to structured data. Guys, Hadoop's solution to these problems ingeniously. Okay, it is used as a replica factor, and it is designed to run on commodity heterogeneous hardware, and it is going to process huge amount of data, and it is going to use MapReduce programming model, and it is used to compute compute is close to the storage. Okay, everything, guys. So everything is to be done by this Hadoop. So I will explain you each and every point in next coming slide. Okay, so this one I already have explained you, right? Now look at here. Okay, what is the different from okay, what's different from the distributed databases? Guys, this is another very important one. Okay, so it highlights the core differences between a distributed database and Hadoop. So this is crucial to understanding when to use which technology. So let's look at the data model first. Okay, this is the data model I have mentioned here. Distributed databases. So they are, okay, so I'm trying to compare both, guys. Distributed databases, they are based on tables and relations, correct? No, with a predefined rigid schema that you define during the write process. and they support partitions and are optimized for fast indexed reads. And they are designed for workloads where you read and write many times. So this is about distributed data. And what about Hadoop? What about Hadoop? Guys, Hadoop is in contrast to your distributed system. Hadoop's data model is based on flat files that can support multiple formats. Okay, so there is no predefined schema. Understand this. So it is just opposite to this. The meaning of this is you can write data first and worry about schema later during the read process. That's why it is called as schema on read. Schema on read. Okay. So it automatically divides files into blocks and handles large files efficiently. Guys, it is optimized for write once, read many times. Try to understand this. So write once, read many times. Okay. So it also meant for full file scans rather than indexed lookup. So which is what gives it high throughput. Okay. Now let us look at one more, that is compute model. So with respect to data model, we have explained what is the difference. With respect to compute model, let me talk about distributed databases. They are built around the concept of transactions. Okay, they are added to acid properties. What is acid properties? Atomicity, consistency, isolation, and durability, right? So this I will explain in the next coming slide, next coming session. So they are designed for OLTP workloads. So where you need to perform many small, fast transactions like insert, updates, delete, so on and so forth. So once I'm talking about Hadoop, its compute model is based on jobs divided into tasks. So here, jobs are divided into tasks. Task 1, task 2, task 3, like that. Okay. So it is going to follow the MapReduce model. MapReduce model. Try to remember this. So every task is either a map or a reduce. I will show you how MapReduce is going to work later. Okay. And it is designed for high latency analytics and data discovery workloads. The meaning of, so you just think of it as a batch processing, large data sets to get an answer, not quick lookup. Guys, now that we understand the difference in principle. So let's quickly look at high level architecture of Hadoop to see how these concepts fit together. Okay. This is Hadoop. Actually, you can go through this, guys. Actually, both I have explained in 2 slides. So this you can see later. Okay. This is Hadoop high level architecture. So here we have high level architecture diagram of Hadoop cluster. So please, everyone take a note of this. This is very, very important. At the core, Hadoop has 2 main layers. So the very first layer is called as HDFS layer and second one is called as MapReduce layer. The HDFS layer is responsible for storage. So this is responsible for storage. Try to remember this, guys. This is very, very important concept. See, whatever the concept I'm going to explain you now, each and everything is important to understand the architecture of your Hadoop, to understand the computation, any of the program in Hadoop. Okay, so this is very, very important. The HDFS layer is responsible for storage and it consists of a single name node. Look at here. Everyone, try to observe here. It consists of single name node. So what is this name node? Guys, this name node is the file system management node. So it is like the master server. So it does not store actual data, but it stores the metadata about the data. Okay, it is not going to store any actual data, guys. It is going to store the metadata about the data, where the files are, which blocks they are made of, where those blocks are stored. Okay, all these informations are going to what maintained by this name node. And next we have data node here. Look at here. Next one is data node. Guys, multiple data nodes. So which are these slave nodes? So this is your master node, right? Name node is behaving like a master node. So here I will be having, see, this is single, but I can have what more number of data nodes in your system. Okay, these are all behaves like a what slave node. And these are the actual nodes that stores the data blocks. Understanding my point? The data is partitioned into files on these data nodes. Okay, so now is this clear to everyone? So what you have to remember, guys, what you have to remember now, what is name node? What is name node? Can anyone tell me quickly? What is data node? Sorry, name node. Name node is what, guys? Name node is a master node, correct? No? So what is data node? Yes, file storage management. So it can have what information, data of what data actually. And what about name node? So name nodes are slave nodes, is it? So which will be having data. This is what you have to understand, guys. This is very, very important. I'm stressing on this. And next, look at here, guys. See, in this layer, in HDFS layer, you have only these two. And what do you have in MapReduce layer? See, MapReduce layer is responsible for processing. So this is responsible for processing. So it consists of a single job tracker. Look at here. It is consisting of single job tracker. So which is the master node for the MapReduce job. So here, this is the master. Correct, no? It takes a job from a client and divides it into smaller tasks. And we have multiple task trackers here. Look at here. We have multiple task trackers. So which runs on the what data nodes. All these are going to what runs on data nodes. They manage and execute the task assigned by the job tracker. This is what you have to remember, guys. This is very, very important concept. You have to remember to work with your Hadoop system. The key thing is to note is that the task tracker are running on the same nodes as the data nodes. And this is implementation of the compute close to storage principle. Okay, compute. Let me write here. Compute close to storage. So the job tracker sends a what? See, look at here. The job tracker sends a task to a task trackers, and thus that task tracker can access the data block stored on its own data node. So this is going to access data from the data node and minimizes the network traffic. And this is the what fundamental architecture of Hadoop. Okay, so how many of them understood this, guys? So how many of them understood this? Can you quickly put a message in chat box? This is the complete architecture of your Hadoop, guys. That's all. Yes or no? So can one task tracker access data from other nodes? No. What is the job of task tracker? What is the job of task tracker? So it will send, see, Task tracker job is to what? Access the data from the different blocks. Yes, sir, of course. See, I'm telling you the same thing, right? I'm telling you the same thing, Priyanka. See, task tracker is nothing but your data node. So which is going to what? Access data from the data nodes. So not only it is going to access in the same node, it will access data from the different nodes also. So this is the foundational architecture of Hadoop. So if you have any question, please do ask me, guys. This is very, very important concept. I'm repeatedly telling you, this is very, very important concept. Okay, practically I will show you later. Practically I will show you later. Okay, maybe yes, I will take one extra class to explain your lab programming. So on that time, I'm going to explain you each and everything. Try to understand the concept what I'm teaching you today. So all these concepts are very important for your examinations. Okay, sir, one more time, a quick flow of the architecture. Yes, look at here. So this is the architecture. You just look at the architecture here. So this is HDFS layer. So this is your MapReduce layer. HDFS layer is called as a storage layer, and this is your processing layer. HDFS layer is containing two things. One is name node. So this could be what always single. So you can have multiple number of data nodes. Okay. And once I coming to the what MapReduce layer. So under MapReduce, we have single job tracker. So this behaves like a master. Here, name node behaves like a master. So job tracker will send a what? Request or task to the task trackers. Task tracker will process the data by taking the what data from the data nodes. That's all. Very simple. Is this clear? Is this clear now? Okay, now let me take one small example to explain the same thing. Okay, this is the word count example I've taken here. So all of them look at here, guys. So this program is written by using Java language, correct? No? This is written by using Java language. Guys, I am not going to use Java language. I am going to use Python language to execute your lab program. So how many of you are familiar with Python? And no need to learn Python also, guys. So once you are looking at my code, then you will understand. So how to write a code in Python very easily. So I think you're all aware of Python language, right? Okay, yes, then no problem for me also, guys. So here we have written program in Java language. So for a time being, I'm going to explain you this, guys. Later on, I will give you program in Python later. Guys, this is the classic hello world of big data. Okay. Okay, the word count example. So it is the simplest way to understand how MapReduce works. Okay, so let's imagine our input data is a couple of sentences. So here we have taken the example. So hello world, bye world, hello Hadoop, goodbye Hadoop. So this is the sentence we have taken here. The process involves two main steps here. What are the two main steps? The very first step is mapper phase, and the second step is called as reduce phase. Okay, so let me explain you the very first one, that is mapper phase. Okay, code I will explain you later, guys. No need to go with code now. So code you can understand very easily. Okay, the input data is split and sent to different mappers. Look at here. Hello, word, by word. So this is splitted and it is sent to one mapper. And again, look at here, guys. Second sentence is sent to another mapper. Okay, the map function, then what map function is going to do? The map function takes each word and transform it into key value pair. transform it into key value pair. Okay, so here the keys are word itself and the value is 1 everywhere. So this is initialized to 1 here. Look at here. So key is nothing but words. Correct, no? And what are the values? So values we have taken as 1. Why we have taken it as 1? Because we have initialized it into 1 initially. That's it. So hello word has become hello comma 1, word comma 1, by comma 1, word comma 1. That's it. So same with respect to the second one also. Correct, no? Yes or no, guys? So this is done in parallel on different nodes. Try to understand this. The output of the map job is returned to intermediate files on the disk. Okay. So under this, it is going to perform one more operation, that is shuffle and sort phase. The second phase I have not mentioned here, but we have shuffle and sort phase in between this. After map phase, a shuffle and sort process happens automatically. All the values for the same key are grouped together. So all the hello keys go to one reducer and all the word keys go to another, and so on and so forth. So it is a kind of what? Shuffling and sorting. So after sorting, so it will go to another what? Another group. That's it. Okay, with the key, it will go to what? Another group. So this is the first phase and this is the second phase. And what is the third phase? The third phase is reduce phase. So this is called as reduce phase. The reduce function takes a key and a list of all its values. It then sums up the values to get the what total count for each word. So for example, look at here, guys. So what sorted function is going to do? Sorted function is shuffled and sorted data, right? Hello is placed in single place actually. This word is also placed in single place actually. And here also we have, okay, this is goodbye. This is, okay, this is separately and this is separate one and this is separate one. So what reduce is going to do, guys? So reduce is going to perform the additional operation, summation operation. So it is going to get the what total count for each word. And the final output would be bye 1, goodbye 1, hello 2, Hadoop 2, word 2. Hadoop 2, yes. We have 2 Hadoops here, correct. So the results are then returned to the HDFS, and this simple example demonstrates a power of parallel processing for even the what most basic task. Okay, so have you understood this programming, guys? Have you understood this programming? This program I'm going to give you in your lab session. I'm going to explain you this program, and even yes, guys, you have to execute this program for different problem statement. Okay, so I have taken simple example to work on word count. That's it. So is this clear to everyone? So can you all raise your hands? So if you have any doubts, please do raise your hands quickly. So are we going to use Python for lab? Yes, Sajid. You are going to use Python. Ravi Kumar, yes, right. You have raised your hand. Please type your question. Yes, Kaushik, you are going to use Python. No worry, Jyoti. It is very easy to understand. And also, you are not going to write 100 lines of code here. You are going to write only 10 or 20 lines of code. That's it. So it is very easy to understand. No need to worry about that. Parallel, you can learn Python also. Python, see, you have started learning Python now means, so within 15 days, you can learn Python. It is not big task. We are going to use very basic concepts in Python. That's it. Otherwise, you are familiar with C programming. That is enough. Okay, C knowledge is enough to learn Python language. So this is going to pull data from files and create the map of each word, making them keys and count. But how this helps in analysis? No, actually, see, this is the word count problem we have taken, right? Number of words we have started counting. So this is not useful in what, NLP, natural language processing. Ravi Kumar, is this not useful in natural language processing? Text analysis. We are going to call it as text analysis, right? I'm not talking about only word count, guys. We have so many problems. See, we can take sales data set. So there also we can do what, some analysis. We can calculate average salary, monthly wise salary, everything we can perform by using this big data actually, or map reduce. Clear? You're all getting some idea, guys? Is it interesting? So once you have started using tools, then you will find the easiness of what, Hadoop tool. Guys, within a fraction of a second, it is going to give a result to you all, guys. That is the advantage of using Hadoop. Okay, it will distribute data parallelly. So it will perform all the tasks and it will what, give result back to you. Sir, before midsem could discuss demo program in the session. Definitely, Kaushik. Definitely, I'm going to discuss one lab program. I will take one extra class to explain you on lab program. No need to worry. See, you people are giving me a time means, then definitely I'm going to explain you everything, guys. So I want you people to commit. That's it. I want you people to give me what, extra time in weekdays or weekends. Okay. So once you are giving weekdays and weekends time is, then definitely I'm going to teach you the programs. I'm going to teach you how to use Hadoop environment, MapReduce, everything. Big guide, everything, guys. We can try with all. That's why we have included what, lab session. Clear? Yes, guys, quickly. No, actually, see, suppose you have a zero reducer means, then what is the use of MapReduce? See, you have to perform some computation, right? Padhyay. See, mapper is going to what, distribute data and it is going to allocate initial values. That's it. But who is going to perform computation? Padhyay, you're understanding. We have to perform some computation, right? Actually, to tackle examination, you have to go through the previous year question paper. You just go through the previous year question paper, then you people will get some idea. But as I told, guys, I'm going to give you more case study based question, scenario based question. See, whatever the concept I'm explaining you, that you have to think in real time and then you have to answer. So this type of question you are going to get in the examination. Sir, what happens in shuffle and sort phase? See, shuffle is going to shuffle the data. See, whatever the data we have taken, so that is separated as a word, correct? No? And it is not sorted, is it? See, and also data is distributed among what, different maps. So shuffle will shuffle all the data and it is going to what, put in a single place. And then sort function is going to sort all the data in alphabetical order. Okay, that will push to reducer. That's it. See, suppose you have hello, 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 hello in one place means, then addition will become very easy for the reducer, right? Jyoti. Clear? Okay, guys, I need to complete so many slides. So every time I'm not going to complete the entire slides. So still I have many slides to complete, guys. So should I start? Okay, once again, guys, it is stuck. So still I am in 26th slide. So I have to complete 63 slides, sir. If I go like this, then definitely I'm not going to complete my syllabus here. Okay, guys, now quickly I will go through the next slide. Okay, you just, okay, let me get the confirmations from you all. So shall I proceed, guys? So if I extend another 30 minutes, no problem for you people, right? If I extend another 30 minutes, no problem for you people, right? I want each and everyone to respond, guys, regarding this. 30 minutes is fine for me. Okay, yes. Okay. Thank you all, guys. Thank you for your time, guys. Even tomorrow we are going to discuss more on this. Yes, these are the advantages of using Hadoop. Okay. So what are this is the key benefits we have mentioned here. The very first one is low cost. This is the very first benefit. So it is an open source platform and it runs on low cost commodity hardware. So this means you can build a massive data infrastructure without a huge capital expenditure. And the second one is computing power. That is one of the biggest advantage of using Hadoop. Guys, Hadoop allows you to use many nodes for parallel computations. So this means you can process enormous data sets much faster than on single system. Okay, that is the second advantage. And third one is scalability is another advantage. So it is a very simple to add new nodes to the system for both parallel processing and storage. The meaning of this is you can scale your infrastructure as your data grows. So without having to rebuild your entire system. And next one is storage flexibility. So it can easily store unstructured, structured, and semi-structured data in a flexible way. So this is a major advantage over traditional relational databases. And finally, we have inherent data protection. Guys, Hadoop is designed to be what? Fault tolerant. Okay, the replication factor we discussed means so that it protects against hardware failure automatically. If a node goes down, the data is still available from its replicas. So maybe I have not explained that concept. Okay, I will explain you that later. Okay, I will explain you that data replication later. Okay, so these are the advantages. So explain why Hadoop became a dominant force in the big data space. Okay, so now look at the ecosystem that has grown around it. So this is the ecosystem. You can quickly go through this. Hadoop is not just a single project. So it is a vast ecosystem of tools, technologies that works together. At the bottom of this stack, we have HDFS. You can observe here. So this is the bottom layer. So we have HDFS. We all know the purpose of using this is to store data. So on top of that, we have Yarn. So Yarn is nothing but yet another resource negotiator. Okay, try to understand the full form of this. Yet another resource negotiator. So this is used for resource management. Okay, so Yarn is the heart of the ecosystem. So it manages compute resources and the scheduling for all the applications that run on the cluster. So this is the main part. This is the main heart of your system actually. Okay, then at the top, we have wide variety of tools for different purposes. Okay, we have MapReduce. So you can observe here, we have MapReduce. So this is the original processing framework, but others have emerged. See, for analytical SQL on Hadoop, so we have Hive and Drill. Okay, for machine learning, so we have Mahout, Spark MLlib. For scripting, we have a separate language that is called as Pig. For NoSQL databases, so we have HBase. Okay, for searching and indexing, so there is a different softwares here. that is solar, where it is mentioned, solar and leucine. And for scheduling jobs, we have Uzi. For management and coordination, we have two. So one is Zookeeper, another one is Ambari. And we also have tools like Flume. Okay, tools like Flume. And maybe you have heard about Scoop, right? So these two are used to ingest data into the ecosystem. Okay. The Flume is for what? Unstructured and semi-structured data. And the Scoop is for structured data from traditional databases. Guys, actually, I just want to tell you one thing. So these two tools are very, very important. Guys, actually, many of my friends are working on this Scoop tool. Scoop what tools actually? Their job, so they are going to what? Take the data from traditional systems and they are pushing the data into HDFS. Guys, their job is only taking a scoop of data, scoop of structured data from the traditional databases and pushing it into HDFS. That's all. And they're all getting very good salary. See, to perform this, so we have to understand a scoop language. That's it. Okay. So it is very easy, guys. Once you know SQL, then learning scoop is very easy. So even suppose you have to push unstructured data, semi-structured data means, so then you have to use Flume. Okay. And next we have one more that is called as Spark. So which we will discuss next, that is included in our syllabus. So this is for in-memory processing. Guys, the key takeaway here is the Hadoop is foundational piece, but it is the entire ecosystem that provides a complete solution for almost any big data problem. Okay, now look at what some of the issues with the original MapReduce and how Spark addresses them. Actually, guys, here MapReduce is inbuilt in Hadoop. Okay, this MapReduce is overplaced by this Spark. So what is the reason? What are the reasons to overplace this MapReduce with Spark? So that we are understanding in the next coming slide. Okay. So to understand that, so I'm going to give you what introduction on in-memory computing. So in-memory is nothing but RAM, guys. That's all. In-memory is nothing but RAM. Okay. Look at this slide here. Guys, MapReduce, try to understand this carefully. Okay. Issues are very, very important. See, MapReduce revolutionized big data processing, but it is not perfect. So it is an ideal platform for complex batch applications like sifting through system logs, running ETL, that is extract, transform, and load processes, and compute web indexes. However, its reliance on persistent storage. That persistent storage is nothing but your HDFS. Okay, so this is for what? Fault tolerance, and its one pass computation model make it a poor fit for two key types of applications. What are the two key types? One is low latency applications. See, for example, a search engine where you need results in milliseconds. That is the low latency application. And one more is iterative computations. So this is a big one, right? So think about machine learning algorithms or graph algorithm that need to run multiple iterations over the same data set. With MapReduce, each iteration would require reading and writing the data to the disk. So which is extremely slow. Okay, this is where in-memory computing comes in. So it is a type of middleware that allows one to store data in a RAM across a cluster of computers and process it in parallel. So hope everyone understood. What is the purpose of using RAM? Why is this important? You can ask me a question. Sir, why is this important? The very first one is speed, correct? No? The very first one is speed. Guys, RAM is roughly 5,000 times faster than the traditional spinning disk. I think everyone will agree with my point. By keeping the working data set in memory, you can get a massive performance boost. That is one reason why we have started using in-memory concept. And one more is native parallel processing. Guys, in-memory systems are designed for what? Parallel processing, which makes them even faster. Correct, no? See, you can see this diagrammatic representation. You can see this diagrammatic representation. Okay, this is clearly showing the what differences. Hadoop MapReduce reads from disk. Okay, this Hadoop MapReduce reads data from the disk. So write to disk and read from the disk again. In contrast, Spark, what Spark is doing, guys? Spark reads from the input, processes the data in memory, and then writes the final output to the disk. Understanding my point, guys? So it is, see, everything is performing in disk only here. But here, the processing is performing in RAM. Okay, so final result is storing inside the disk actually. So this is the key to its speed. Okay, now look at here, guys, what Spark can do. So quickly, I will go through the fast and easy big data processing with Spark. Guys, I'm giving you only introduction. So I'm going to give you more information on this in Spark class actually. Guys, Spark is a general purpose programming model that lets developer write applications by composing arbitrary operators like mapper, reducer, joins, group bys, filters, so on and so forth. This makes it easy to express a wide array of computations, including iterative machine learning, streaming, complex queries, and batch processing. The key to Spark performance is its ability to reliably store data in memory using RDD. So it is going to use the concept of RDD. RDD is nothing but resilient distributed data set. Guys, Spark keeps track of the data that each operator produces. And by caching this data in memory, it avoids costly disk access. Okay, so look at the, again, that word count program. Once again, guys. Once again, guys, I will show you this program now. See, look at the program here. How many lines of code we have written? You have seen, right? Previously, how many lines of code we have written? Now, how many lines of code we have written? See, this code snippet on this slide is the very good illustration. See, look at here, guys. Spark context dot text file, and then we have taken the what file name. This command reads data from the source, but the data should be present on HDFS, guys. That is must. Okay, and next line, look at here. Dot flat map I have written, right? So this splits each line into individual words. The only one line is splitting data into individual words actually. And what is the next one? See, I'm calling mapper function here. So this function creates the key value pair for each word. And next I'm calling one more line. So reduce by key. So this function aggregates the counts for each word. And finally, you are storing back to the what? Disk actually. Okay, look at here, guys. How many lines of code you have used here for what word count by using Java? And how many lines of code you have used here? This is the key difference, is that the output of map and reduce operation is written to memory, not to the files on disk. So don't worry about number of lines, guys. Number of lines and all we can think later. But where it is storing data back, it is storing data back to the RAM, not to the disk. Okay, you can then write the final memory content to files if you want to. So this provide much richer set of primitives on top of MapReduce model and making it easier to program and much faster. Okay, guys, you people are going to what experience both. You are going to write the word count program in MapReduce, and the same word count program you are going to write in Spark also. No need to worry now. Okay, so is this easy? Now, how you are all feeling, guys? So how you are feeling now? Rahul, I have to complete the syllabus. I have to complete the syllabus. There is no corruptions of data. There is no corruptions of data. So why you people are saying, am I boring you guys? Am I boring you? Okay. So you people are saying it is too much means then how when I'm going to complete the syllabus. See, tomorrow we have to conduct a fifth session, right? But still I have not started with fourth session. So I'm in what? Only third session. When I'm going to complete the syllabus. Guys, mentally you have to prepare for the extension of class, guys. Otherwise, I can't complete the syllabus. Yes, it is too much, but what should I do? So you people can go through the recordings, right? But what about me? So we are moving very close to examination, midterm examination. So before that, I have to complete all 8 sessions concept, is it? So based on your, see, I asked you people to what continue, right? Shall I give 5 minutes break? Shall I give 5 minutes break? Is it okay for you all? Okay. Okay, guys. Now I'll give you 5 minutes break. So after break, we will continue, guys. Please don't think bad about me. Yes, I know you're all working people, and also you're all understanding this concept the very first time. So it is too much for you people, but you have to understand my situation also. So before your examination, I have to complete the syllabus. Correct? No. So we have to touch upon your lab session also. So for your assignment, for your lab exercise, so we have to start with this, right? So please try to understand. Okay, guys, after 5 minutes we'll meet. Now the time is 8:40. So we'll meet at 8:45. Is it okay for you all? So Priyanka, sir, post break, please end the class by 9. Okay, okay, Priyanka. Sure. Okay, guys. So shall we start the session? Now the time is 8:45. Shall we start the session? So can someone? Yes. Okay. Yeah. Without wasting time, so let's quickly complete all this topic. Yes, I was talking about this, right? Ideal Apache applications. Guys, actually, yeah, this is highlighting two ideal applications for Apache Spark. So one is low latency computations. The meaning of this is for applications that require quick queries and responses. So Spark is a perfect fit. Okay. And the second one is efficient iterative algorithms. So this is a what big one, right? So especially in machine learning and graph analysis. See, many algorithms like k-means clustering. So these are all need to run multiple iterations over the same data set. So with Spark, subsequent iterations can share data through memory. So avoiding the needs to read from disk over and over again. So this makes these iterative computations much more efficient. Okay, so you can observe in this diagram. So this diagram, so visually represent those two use cases. The first shows, this diagram is showing what? Multiple queries running on the same distributed memory. And the second one is showing, what is the second one is showing, guys? The second one is showing multiple iterations of the computations all happening in memory. See, Spark has become an extremely popular technology because it addresses the shortcoming of the disk-based MapReduce model. So particularly for iterative and low latency workload. Okay, so now look at here, guys. Now let us talk few things about cloud computing. Okay, so even I'm giving you introduction on cloud also. So let's talk about cloud computing. See, many of you are probably already using cloud services, but let's get a formal definitions from the US National Institute of Standards, that is NIST. So NIST defines cloud computing as a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. So that can be rapidly provisioned and released with minimal management effort or service provider interactions. Guys, there are few key phrases in these definitions. See, the very first key phrase we have used as ubiquitous, and second one is convenient and on-demand network access. So you can access it from anywhere, anytime, only when you need it. That is the meaning. And we have used one more keyword, right? Shared pool of configurable computing resources. So the meaning of this is the resources are shared among multiple users and it can be what configured as needed. And finally, so we have mentioned one more keyword here, that is rapidly provisioned and released. Guys, you can get the resources you need in a minute and release them when you are done. So you only pay for what you have used. Okay. And NIST provides helpful 3-4-5 rule of cloud computing. Okay. So what is 3-4-5 means? 3 means cloud service models or service types for any cloud platform. 4 means deployment model. 5 means essential characteristics. Okay, let us look at the very first one. What is the very first one? Okay, the very first, see here, I'm trying to explaining you the characteristics of cloud computing. Okay, so 5 essential characteristics of cloud computing is listed here according to NIST. The very first one is on-demand self-service. You all know the meaning of this, right? So consumer can what? Unilaterally provision computing capabilities such as server time, network storage as needed automatically without requiring human interactions with each service provider. So it is like water, what fountain, guys. You go and get water when you need it, and you don't need to ask anyone for permission. And broad network access, the second one. The capabilities are available over the network and accessed through standard mechanism that promotes use by a wide variety of client platforms such as laptop, mobile phone, tablets, whatever you want. And resource pooling is the third one. The providers computing resources are pooled to serve multiple consumers using a multi-tenant model. Okay, the resources are dynamically assigned and reassigned according to what consumer demand. And one more is rapid elasticity. So capabilities can be elastically provisioned and released here. So in some cases automatically to scale rapidly outward and inward, commensurate with demand, and measured services at the end. So cloud system automatically controls and optimizes resource use by leveraging a metering capabilities. The meaning of this is resource usage can be monitored here, controlled here, reported here, and providing transparency for both provider and also consumer. So this is the pay per use model, like measuring cup for ingredients. Guys, these characteristics are what make cloud so powerful and a great fit for big data. Okay. And see, we have a deployment models. So we have 4 deployment models actually. First one is public cloud. Maybe you have heard about it. So your AWS, Azure, Google Cloud. So these are all called as what, guys? Public clouds, is it? So this is one we are all almost familiar with. The cloud infrastructure is made available to the general public. That's it. And it is owned by an organization selling cloud services. Okay, example already I've told you. And the next one is private cloud. So see, guys, the cloud infrastructure is operated solely for an organization. That is called as private cloud. So it can be managed by the organizations or third party. So it can exist on premise or off premise. So that is called as private actually. And once I'm talking about security, see guys, it offers more control and also security, but lacks the cost effectiveness and scalability of public cloud. And third one is called as hybrid cloud. So as the name indicates, so this is a composition of 2 or more clouds. So which could be private or public. Okay, they remain unique entities but are bound together by technology that enables data and application portability. And finally, we have community cloud. So maybe you have heard about this. So this infrastructure is shared by several organizations and supports a specific community that has shared concerns. Okay, such as security requirement or a common missions. So it can be managed by one of the organizations or third party, and it can be on premise or off premise. Guys, these models give organizations flexibility in how they choose to deploy their cloud infrastructure. Okay, then what are the cloud service models? I think maybe you all heard about this, right? The very first service model is called as infrastructure as a service. Okay, this is the most basic service model. What you can do here, guys? You rent processing power, you rent storage, networking capabilities from the cloud provider, and you are responsible for managing the operating system, applications, data. Guys, AWS and Rackspace are classic example for IaaS provider. Okay, so and next one is platform as a service. That is the second one. second service model available in a cloud. So in this model, the cloud provider gives you a platform to deploy customer created applications. You don't have to worry about the underlying infrastructure like servers or storage. You just focus on deploying your code. That's all. Okay. So example includes Google App Engine, Windows Azure. So these are all best example for platform as a service. And finally, we have a software as a service, SaaS. So this is the most complete model. The provider gives you a finished application that is ready to use. You don't have to worry about the infrastructure. You don't have to worry about the platform or application itself. So it is fully managed. So Salesforce is the best example, right? Salesforce CRM is the great example for SaaS provider. This is like using a taxi. You get in and tell the driver your destination. That's all. Guys, these models provide different levels of control and management. So allowing you to choose right one for your needs. Okay. And see guys, now cloud servers for big data. Cloud servers for big data. Guys, the cloud and big data are a perfect match. My dear friends, both rely on distributed cluster of computing devices. The cloud is considered an ideal platform for handling big data for a few reasons. What are the few reasons? First one is IaaS. See, this model can provide the huge storage and computational power requirement for big data. So example for this is AWS S3 and EC2. And PaaS, platform as a service, this model saves a lot of hassles. So vendors offers platform with Hadoop, MapReduce, ready to go, like AWS EMR. So this saves hassles of installations and management of this environment. And finally, we have SaaS. So this is the great help for organizations that need specialized big data software, but don't want to manage the underlying systems. See, for example, SaaS vendors provide out-of-the-box solutions for things like social media analytics, feedback monitoring, so on and so forth. Guys, many of the big cloud providers have a strong presence in the big data market. Okay, so your AWS. So AWS offers EC2, Elastic MapReduce, and DynamoDB. And maybe you have heard about S3 and Redshift. So these are all provided by the AWS. And even Google is also providing many. Guys. Google offers Google Compute Engine, BigQuery, Google Prediction API. And Windows is also providing many. Windows Azure. So this Azure provides PaaS, Windows Azure HD Insights. Okay, so here we have what cloud providers in big data market. These are all cloud providers in big data market. So everything I have explained you, right? Understanding? So next class I will take you this case study, guys. So now, as I told, the time is very close to 9. I don't want to continue with this case study. So this case study I will explain in the next coming class. And yes, I have to complete few more slides. There we have some numerical problems that I will cover in the next coming class. So tomorrow I'm going to cover all these things, guys. So is it okay for you all? I think many of you are fed up with today's session. Yes, we are going to cover it in cloud, but still, so actually, see, that is there in second part, right? So now I'm giving you introduction. Introduction means it is a kind of what understanding. Guys, your midterm examination is closed book. See, in closed book examination, I have to look at what most of the questions on understanding. Most of the questions on remembering. So that's why, so first 8 sessions, they are concentrating on introduction part. So later on, they are going to give depth knowledge on each and every concept. Okay, so okay guys, that and all we can discuss later. this is my sincere request, guys. All of them go through the lab access. So whether it is available for you people or not. So once it is not available to anyone, please to inform to operational teams to get an access of your lab. I think every one of you are getting this access. Correct, no? Okay, Ravi Kumar raised his hand. Ravi Kumar, tell me, please do type your message in chat box. In our next session, we will dive deeper into CAP theorem and big data lifecycle. Okay. Sir, will today's slide uploaded to Tuxila today or will it be uploaded after tomorrow's session? I'm going to upload today only, Mohnish Saini. Can you show lab exercise URL? What lab exercise URL? I'm not getting Ravi Kumar. You want me to show the link of that? You just go and put a message in Google, OSHA bits Pilani. So it will redirect you to the login page. What to do in the lab? Anything we need to do in that? Yes, you have to execute MapReduce program. You have to work on Hadoop commands. You have to write a program in Spark. You have to write a query by using what Pig, Hive, so many things. Okay. So lots and lot of tasks you are going to do in lab session. So that is clearly mentioned in your this one, no? Handouts. You just go through your handouts. So it is mentioned in handouts. Lab programs are mentioned in handouts. Okay. Guys, I hope you found this session insightful. Yes or no? So can you all type insightful in chat box once it is insightful? Lab access. Yes. Yes. Remember, guys, the journey of 1,000 miles begins with a single step. And you have just taken a big one in your understanding of big data system. Keep exploring, guys. Keep questioning and keep learning. Okay. So yes, tomorrow I'm going to start with the fourth session concept. Okay, in fourth session, we will try to cover. Many of them are asking about acid property, right? I'm going to cover acid property and CAP theorem. Along with that, big data cycle. So these three concepts I'm going to cover in tomorrow's session. Okay. So that is your fifth session concept. I have to take one more extra class to complete the sixth session concept. So lab will be do in regular session or extra session. So in extra session, actually, Prasiddha, see, in regular session, I'm not able to complete my syllabus only. Correct, no, Prasid? Pradeep, sorry. BDS you have to choose. Big data system. Okay, some big message I got here. Hi, sir. Feel free to ignore this queue if it is not relevant. I believe Databricks is an alternative to. So if that's correct, my organization is using Databricks. So could you please help me to understand on what scenario an organizations might choose to use Databricks over Hadoop? I believe Databricks have some cloud native advantages. So I am from development background. Okay, this is the big question I got from Gautam. Gautam, I will answer you tomorrow. Okay. So with otherwise you put a message on mail. I will give you solution on mail. Okay. This is a very good question. I will answer you personally through mail. Okay, you put a mail with the same message. Yes, guys, how was the session? It is too long session, is it? 2.5 hours in Saturday. I am not getting any responses. Yeah, bit long but insightful. Yes. Thank you, sir. We'll join back tomorrow. Session was good and everything was delivered greatly. Thank you, guys. Thank you all, guys. So see you all in tomorrow session. Thank you, guys. Good night.